Now let's start writing in-order traversal of binary tree in an iterative way. So let's add a function signature in-order traversal. We need a root. So let's copy the function signature, go to Traversals file. Let's start implementing this. So generally, first line that we want to print is a message that we are printing in order traversal. Then the first check that we generally do is if root is null, we return because there is nothing to print. After that, let's get into creating a stack. Because we are writing iterative version, we'll need a stack. So let's call create stack, and at the same time let's add a call to destroy stack also. Yeah. So the strategy that we'll follow is we'll put a loop. First we will traverse left, then we will print value, then we will traverse right subtree. So the way to traverse left subtree is, while our root is not null, we keep pushing our node address onto the stack. So push s root, and after that we move root equals root left. So with this we are making sure that any node that we encounter on left subtree, on left path of root, that we are putting onto the stack. So we have to make sure, like, we have to remember that anything that is there on the stack is yet to be printed. We have not printed it because its left subtree is not yet covered. Because in-order traversal requires first left should be printed, then root should be printed, then right should be printed. So if we take an example of this subtree, this tree, then what we want, from 2 we want to move to 1 to 5 to 4. We cannot print 2 directly because it still has its left subtree. So first thing that we push is root, then we move root to root left, then we push 1, then we push 5, then we push 4. After 4, if you see in this loop what will happen, if root is pointing to 4, that will be pushed onto the stack, and then we are moving root equals root left, that is left of 4, which is null. So we come out of this loop. So once we are out of this loop, that means the last item that is there on the stack, it does not have any left child. So what we need to do, we need to first pop 4. And since root is null, we can use root variable directly, pop of s. We have got 4 out. So once we have popped a value, next thing we have to do is we can print it directly because its left subtree is already covered. So printf of %d root data. So now we are in a position where we can print this value. And after we are done printing, then what is the next thing we do? After 4 is printed, then again we should go to the previous element, which is 5. That means a next pop from stack should happen. 4 is popped, 4 is printed. Now we want again a pop should be happening from the stack. So if, let's assume, if 4 had a right child here, if 4 had 7 here, rather than pop of previous item happening, we should ideally be going to traverse the right subtree of 4 after printing the 4. So after the pop has happened, what should we do? If the item that we have taken out, if root of right is not equal to null, that means it has a right child. So what should we do? We should proceed with root equals root right. Otherwise, what we want, right now root is pointing to the element that we have popped. Otherwise, what we want, it should go up and pop should happen. In order to force this function to do a pop, root should be null. If root is not null, we'll enter this while loop. So let's do in else part root, let's make it null. So with this, it should be able to print our in-order traversal of tree. So let's go ahead and add this call into main, and we call in order traversal and I say root. So compiling this program, it compiled successfully. Let's run it. Oops, assertion happened. There is one check that we missed putting in our in-order traversal, so we'll go back and address that check. And that check is, we are making a call to pop without even validating if our stack is empty or not. Because if stack is empty and we make a pop call, that will be invalid operation. So if is stack empty s, then ideally we should never go to pop. Stack is empty means we have printed all the nodes, so we can simply break and come out of this. So now if we run this, you should be able to see in-order traversal, it's 459. Then after left is done, we should print 1. After this is done, we should print 2. After that 3. So in-order traversal is giving us 459, 1, 2, 3 as an outcome, which is correct.